Hey Math 206 students, so I want to follow up with the construction we just did, side, 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 with the triangle inequality. So this actually you can see from the construction that the sum of the measures of any two sides of a triangle must be greater than the measure of the third side. So we have a triangle activity sheet that we could do in class. Maybe we'll do during office hours. But here's basically the idea of that sheet. Suppose I had one side of my triangle was 2 inches long. And suppose the other two sides of my triangle are only half an inch long. Let me set my compass length to half an inch. If I do that, from this first vertex, here's all of the points that are half an inch away from that vertex. And suppose the other side length is also a half an inch. Here's all the points that are half an inch away from this second vertex. What you should notice is that these two circles don't intersect, basically because these two lengths are too short. They're not going to close up. So, if you were to draw out the other two side lengths, they would just be too short. They don't meet up. Now, I drew this line segment so that it was 2 inches long. What if I said each of the other two sides were 1 inch long, like halfway there? Let me just go ahead and set the length, my compass arms, to 1 inch. What would happen then? Here I'm drawing a circle of length 1. This denotes all of the points that are 1 inch away from this vertex. And here I'll draw all the points that are 1 inch away from my second vertex. What you should notice is that these two circles sort of do intersect, but they intersect on the other side of the triangle right there. So basically what you get is a degenerate triangle. This is side A, B, and then your third vertex would be here on the line segment from A to B. So in this case, you have side length 1, and then this side length here is 2. So that's a degenerate triangle when two sides add up to the third side. Can't have that. So the triangle inequality says that the sum of the measures of any two sides have to be greater than the measure of the third side. Let's see if these triples will produce a triangle or not. 10 centimeters, 5 centimeters, 3 centimeters. Is it possible to draw a triangle with those three lengths? The answer is no, because 5 plus 3 is too short. It's less than 10. So you can imagine having 10 centimeters here, and then 5 would be like less than halfway, and then 3 centimeters would be even shorter than that. These two sides would not meet up. How about 3, 4, and 5? Take the two smaller sides. 3 plus 4 is greater than 5. So yes, these three lengths will give you a triangle. How about 100 miles, 42 miles, 84 miles? Well, let's add up the shorter two sides. See what that adds up to. That's 126 miles, which is longer than the longest side. So this is greater than 100. So we get yes here. So you'll have a few homework problems asking you to decide if a triple of lengths gives you a triangle or not. All right, so now that we understand the triangle inequality, let's move on to a different type of construction. We know how to construct side lengths by copying the side over using my compass. Now what we'll do is construct angles. So basically I'm going to copy this angle B over. And the way that we do that is we will be basically drawing a little triangle here inside of this angle and then copying the triangle over. If you copy the triangle over, then you know that that angle has to be congruent to the angle that you copied over. All right, so here's how we do that. First, here's B. Let me copy B prime over, and actually I'll copy over an entire ray. It doesn't matter how long I draw it. So I've got, here's one ray, here's a second ray. Now, what I'm going to do is to take my compass and set it at any length I want. Doesn't matter. Set the point at my vertex, and then make an arc that intersects the two sides of the angle. And then I'll name those intersections if it helps. I'll call that point A and this point C. Notice what you've done here is you've just kind of created a triangle with those three sides. So what I'm going to do is copy that triangle over by keeping that same length, whatever I had drawn over here, copy that same length over from vertex B prime. The next thing I need to do is figure out what this length is, and I'll copy that length over as well. So I will measure now length AC and copy that distance over here, basically to find this matching corresponding vertex. So if this point is C prime, again, here I'm measuring the distance between A and C. So now I'll put my point at C prime and draw an arc to represent that same distance. And this point, this intersection point, will be A prime. Now the last thing to do is to draw another ray connecting A prime to B prime. And I've copied over the angle. Again, the reason that that works is because basically this triangle ABC here is congruent to this triangle that I've constructed, A prime, B prime, C prime, and then corresponding parts of congruent triangles are congruent, so that tells me that this angle here has to be the same as that angle.